Ladies and gentlemen, welcome to Tormont's Power Systems webinar on generator set noise and emissions. This is part of Tormont's Let's Talk Energy series. Before we get into the details of the webinar, there is a disclaimer that I'd like to share with everyone. This presentation and the information contained herein are provided without a prejudice basis and does not constitute, nor it should be constituted to constitute legal advice or guarantee, offer, representation, or warranty on behalf of Tormont. The panel members will be offering suggestions to several possible customer scenarios. The answers given by the panel members should be used as a guide only. This webinar is being recorded, so please be aware of that. If you wish not to be recorded, you may leave the session now. Safety is paramount at Tormont. Please be safe. Every employee safely home every day and stay in this hot warm weather. Please stay hydrated. Please be present, seek and share and listen and champion the causes. Let's conduct the business in the right way through our values, ethics, and compliance. Cybersecurity is paramount, so it is our shared responsibility to make sure that this is curbed. I am Sharanjit Singh. I'll be the moderator for today, and I'm the mechanical engineer and currently the business strategy and rental operations manager at Tormont CAT. We have a exciting experienced group of panelists here today. The first one is Mr. Greg Fullerton. Greg is the president of Fulco and Blue Frog Environmental Organization, and he has been skilled in Ministry of Environment approvals, compliance, auditing, noise and emissions, especially in the province of Ontario. So Greg, welcome to our panelists here. Would like to say something to our participants?
Thank you. Yeah, I am just looking forward to provide some more information on the approvals process and some of the insights with regards to standby generators versus prime power generators, and just nail that a little bit further for our guests.
Thank you very much, Greg. The next member of our panel is Omar Bakar. Omar is a mechanical engineer, EINT, and also a PMP certification with more than 15 years experience in energy project management. Currently, Omar is the Senior Application Support Specialist at Tormont Power Systems. Omar?
Hello, everyone, and welcome to our session. I just want to, I have a very important comment that sometime the subject of emissions, it's a very broad subject. So if anything is not clear or you have a specific case, you can always reach out to us and we'll be happy to support. And we don't expect that everything to be crystal clear. Sometimes it's a little bit vague, but we are always there to support you. Thank you.
Thank you, Omar. Last but not the least, the member of our panelist is Daryl Follett. Daryl has over 20 years of experience in reciprocating equipment. He is a graduate of McMaster University in materials, metallurgy, and materials. And Daryl currently is Tormont Power Systems operations manager a regional manager for Ontario. Daryl?
Thanks, Sharanjit. Yep, looking forward to talking to everyone here. And a little later, I've got quite a bit of experience dealing with the after treatment and emissions regulations from a operations and product support angle. So I'd like to share some things with you later on in the session about that as well.
Thank you very much, Daryl. So the agenda for today is we will go through the federal and Ontario exhaust emission regulations. Obviously, there is a difference between the two, and also the path that one needs to follow through to obtain approvals. And Then Daryl will highlight some of the maintenance and installation considerations for emission control systems. And then we have our question and answers. So let's proceed on. So Ontario and federal non-emergency emission regulations. Oma will highlight to us the regulatory framework and the classification of the non-emergency requirements, both from a federal and a provincial perspective. So Oma, over to you.
Hello and welcome everyone. Thank you for joining today. So today we'll talk about the non-emergency. First thing, we'll talk about the non-emergency applications. This is where the regulatory requirements become very significant and stringent, and operational flexibility for this decreases. As we see here, so basically any stationary generator that's operating outside of emergency situation requires an EPA certification and must follow the emission regulations that are outlined in the SOR 259/2020. Please note that this is true for the stationary diesel generators, the mobile diesel generators, and the mobile gas generators. On a side note, stationary gas generators on federal level are regulated by what's called the MSAPR, or the Multi-Sector Air Pollution requirements for Ontario, and are not subject to the SOR federal regulations. The off-road compression ignition, so basically mobile and stationary generators and mobile large spark ignited engine emission regulators were published first on December 2020 and then came to force on June the 4th of 2021. The requirements, so basically when you take a look at these two, these are regulated on a federal level, but for the Ontario requirements, when we have a deeper look, we'll find that the Ontario requirements for the stationary diesel and the stationary gas generator sets are more stringent than this. Okay, can we please have the next slide? Because we started with the non-emergency, can we jump to 3 slides, please? There was just another one. Yeah, and another one. Yeah, the one after this. Yeah. So basically, when we talk about non-emergency generators, here we see non-emergency generators. They cover a wide range of applications that are not are not under an emergency requirement. So basically, here we see that the non-emergency power refers to the use of the generator outside through emergency situations. This can include peak shaving, load management, demand response programs, prime or continuous applications, or even temporary power for construction. Sometimes people think that temporary power for construction can have an exemption, but this is not true. Even temporary power for construction, this also lies under the non-emergency use. From a compliance standpoint of view, a non-emergency generator must meet the EPA Tier 4 final standards, and this comes into effect on the June 4th, 2021. So if an engine is dated before this date, it must not follow this. And now we're talking about stationary. Take care, because like we see here in the chart, this is divided into stationary and mobile. So for stationary, it came into force on June 4th, 2021. And then it must be covered by an EPA certification and Tier 4 final. This is on the federal level. For mobile generator set, this regulation started back about 2006. And then as we see here that the mobile generator sets, as we progress from 2006 to 2015, the tier level of the emissions that the mobile generator set must follow changes. So it changes from 2006 to tier 3, then it goes to tier 3, then tier 4, then tier 4 final. So it must be taken on a case-by-case basis that when we look at a mobile generator set that will be used for a non-emergency generator, for non-emergency situation, we must look at the year that it was manufactured and see which emission levels that it complies. Then we move to the Ontario emissions regulations. In Ontario, both diesel and gas generators must comply with the emission limits and operating conditions for non-emergency use. So Ontario regulations, they regulate the stationary generator sets, and they do not regulate the mobile generator sets in non-emergency use. This makes non-emergency projects more complex from a regulatory and a design perspective, where we may need after treatment extra in the Ontario situation, because Ontario requires the NOx levels for non-emergency stationary generators to be 0.4 gram NOx. And actually 0.4 gram NOx is more stringent than the tier 4 final requirements. So we have to keep always in mind that Ontario, for non-emergency use stationary engine, has more stringent requirements than the federal level. Now can we move back to the first part and talk about the emergency situation? Yeah, okay, this slide. So here when we talk about emergency generators, so basically under federal regulations, a standby generator is defined as a stationary compression ignition engine. So I know it's a little bit confusing. So first we talk about non-emergency regulations. Now we talk about emergency situation, and we are going to define the emergency situation according to the federal law now. So basically, a standby generator or a standby engine is a standby stationary compression ignition engine, and this definition is very important, where it refers only to the compression ignition engine. It's a stationary compression ignition engine, so it's a stationary diesel engine that's intended to provide electrical power or mechanical work during a power outage. So it doesn't synchronize to hydro or to utility. It doesn't provide peak shaving. It doesn't provide, for example, load sharing. It doesn't provide this. It's just used during an outage. For this engine to be compliant, it must follow or must carry, for the current regulations, an EPA certification. These requirements have come into effect on June 2021. Stationary generator before that date are not regulated. So if you have a stationary generator that's used for backup and dated, for example, 2018, 2017, this is not regulated. It's only regulated after June 4th, 2021. But on a side note, we must mention that gas generator sets, when they are stationary, they are regulated by something called the Multi-Sector Air Pollution Act. That's a federal regulation that regulates some industries, but not all industries. So if you have a stationary gas generator, it's regulated under the Multi-Section Air Pollution Act, and it's not regulated under the federal law. So there are only about 12 industries that need the engine or the stationary gas generator set to carry an EPA certification for it to be approved to this industry. Can you have please the next slide? So here, this slide shows the emission levels or the federal exhaust emission levels for standby application. And this is strictly for standby application. So basically, this is the federal emission standards for standby diesel generators. Generally, they have to be EPA certified. And this depends on the engine size. So this does not depend on the power that the generator generates. So we must look at the brake power that's coming from the engine. And then this brake power will determine what's the tier level or what's the EPA tier level that the engine will carry. So like we see here from the table, that any engine with the brake power of between 19 and 37 will have a tier 4 interim certification. Any generator with a brake power between 37 until 560 will carry a tier 3 EPA certification. Anything about 560 above that will carry a tier 2 certification. But this is on the federal level. So this is for all Canada. But when you come down to the Ontario level regulations, there are some points that must be taken into consideration that Ontario mentions. The first thing is that it has to operate only during a power outage, and it has to be at tier 1 emission levels. And there are only limited hours for operation and maintenance and testing. Also, Greg will talk into this more deeply as he's like presenting on the subject that are specific to Ontario. So this was a top overview of the non-emergency and emergency cases that we can meet and their emission levels. I know that the title is a little bit confusing, but if you need anything, you can always reach out to us. And now I'll leave it to Greg to go further into the Ontario regulations. Thank you.
Well, thank you very much, Omar, for your insight on the federal and Ontario regulations for both for standby and for non-emergency operations. Obviously, there is a difference between the two, so we've got to make sure that when we're using generator set, we comply with both the regulations here. Now we get into the stuff where it's how do we meet compliance, making sure that the generator set is installed correctly, it meets the local buys laws, meets the constraints, and what are the exemptions. And this is where we have our expert, Mr. Greg Fullerton. So Greg, the floor is all yours.
Great, thank you very much. Okay. Just before I get started, I just want to start off by saying most generators today meet the tier 1 emission criteria for diesel. Most new generators for natural gas meet the 9.2 grams per kilowatt hour NOx in stack limits for standby generators. And most of them meet the 75 decibels at 7 meters. So most generators today that you're going to find are going to be exempt from requiring a formal environmental compliance approval. I just want to throw that caveat out there. You're not going to find a lot. There are some places, older facilities, that might have a diesel or gas engine that just refuses to die and continues to operate pre-tier 1 emission criteria and pre 9.2 gram per kilowatt hour in stack limits for NOx for natural gas. If that is the case, the generator system as a whole, you would have to seek approval for those particular generators, or you can install pollution control equipment to bring it up into the standby generator exemption criteria outlined in OREG 52498. Sorry, I'm coming off a bit of cold. So that's what I wanted to start with. My presentation will round out basically making sure that when you install a generator that may be exempt, that you're installing it properly, that you're not creating more problems than you are solutions for your clients. And I'll get into that. I have a picture at the back that will kind of go over one scenario of many that I've come across. So during this session, we will discuss the approvals process for generators, standby and prime power. We will want to talk about the in-stack limits for prime power generators used for global adjustment. Those require approvals regardless. Those are completely independent of standby generators. Standby generators can only be tested, I believe, for up to 60 hours in a year before they start to fall out of the standby power rating. Standby generators that meet the criteria of OREG 52498, you're going to hear that a lot. 52498 is basically the exemptions regulation from formally seeking an approval from the Ministry of the Environment. And then the very last diagram that I have for you are precautions to take to ensure no adverse effects are realized after the installation of standby generators that are exempt from requiring MEC approvals and permits. And we'll go over that in detail. We'll go to the next slide there. So I apologize, this is a lot. We'll try to keep up, but that's what there's Q&A for too. Hard to do 20 minutes for this. But generators may be required to obtain an environmental compliance approval under OREG 419.05 or an air emission ESER permit under OREG 117 if they do not meet the exemption requirements, which we discussed, most of them do. And that's under OREG 52498. However, most current standby generators meet the exemption requirements. Sorry, double talk there. Both regulations are similar in information requirements. Information requirements, if you're preparing an application for approval, you either have to determine if you're preparing an approval under Reg 419 or if you're preparing an approval under Reg 117. The main difference is Reg 419.05 ECA applications look after larger, more complex facilities. And that could be chemical manufacturing as an example. That's something that the ministry considers a little bit more of a larger risk, and they would like to review those applications in-house prior to issuing the approval. The applications under Reg 117 handle less complex scenarios. That could be, for example, peak shaving that's less than 25 megawatts. So if you're getting into global adjustment and you have a natural gas units that cumulative are less than 25 megawatts, you get that application prepared and signed off by a QP, which is a licensed engineering technologist or a professional engineer, and upload to the ministry website. Now, both regulation requires contaminant emission concentrations to be calculated for all significant emission sources that discharge a contaminant to the atmosphere from the subject facility. If we just go to the next slide. The significant contaminant emissions, and this could be from, let's talk about global adjustment, a 5 megawatt generator. If you're looking to put that in at your facility to take advantage of peak shaving or GA, the significant contaminant emissions from that specific equipment must be modeled along with any other significant equipment at site, so it's a cumulative base. Must be modeled, use what's called Screen 3 or AirMod dispersion modeling, just to assess those contaminant emission concentrations from the equipment along the property line and off the property line at sensitive receptors. If the concentration is below the MECP threshold, no further actions required. You meet the criteria with the ministry. There's same structure contamination assessments that fall into play as well. And it's required when a generator is being installed at a sensitive receptor, such as a long-term care facility, retirement residence, hospital, etc. This will ensure that when the generator is put on test, there are no adverse effects being realized by the occupants of the site. Same structure contamination assessments are typically run by using SCORE Barrett, discrete AirMod receptors, or ASHRAE. And it is important to note that, again, this is mainly typed out for the reason of if you've got a 5 megawatt generator set for global adjustment. If we can go to the next slide. Now, the dispersion models that are used under guideline A11 that the Ministry of the Environment has published for everyone to review. We've got the Screen 3 model requirements. If you run Screen 3, it shows compliance. That's all you need to do. Your assessment's completed. Screen 3 is kind of a quick and easy and dirty model. Tier 2, if it doesn't show compliance, you can go to another level of refinement where the US EPA models with regional meteorological data sets will be used, and you're going to assess compliance with the regional meteorological data sets, not just a set-based data. Tier 3, if you didn't show compliance there, you're running into refined models with local meteorological data sets that show compliance with effects-based standards with appropriate averaging time or the use of alternative models such as CalPUF or anything else to that extent. But if you don't show compliance with any of those, you need to go back to your assessments and make sure you've got all your numbers right and make sure that the facility you're working for does in fact show compliance. And next slide, please. Okay, so I went over this quickly, but the Tier 1 assessment represents the most conservative assumptions about meteorological conditions and modeling inputs. And Tier 2 and 3 modeling assessments represent more sophisticated, precise, and accurate modeling inputs and scenarios. The most significant difference between both of these models are the use of more refined MET data, which we discussed. Next slide. So when running AirMod dispersion models, the program takes into account the following parameters: meteorological data sets, terrain data, building downwash. It calculates effective wind speed through the plume, nested grid receptors, discrete receptors, and more. So this is vastly better than Reg 308 or Run 308, if anyone ever recalls those. But that's a better dispersion model to use to get more accurate contaminant concentrations. Next slide, please. This is just a sample output of what you would get. Let's assume the generator is on the roof here. When you run it through AirMod dispersion modeling, you're going to get an output similar to this, where the red represents the highest concentrations up at about 196 micrograms per cubic meter. And then as you get a little bit further away and dilution takes over a little bit as well, you're going to get into the green and the darker greener shades, which represent much lower concentrations. So it shows you the most serious impact is directly surrounding this building. Next slide, please. Okay, depending on how close the nearest off-property sensitive receptor is, an acoustic assessment may be required to verify the noise emitted from the site-wide equipment on site to determine if the cumulative noise is below the criteria outlined in the Noise Pollution Control Guideline NPC 300. That's a provincial document. If a standby generator requires an approval, and again, this goes back to a really old generator sitting in a facility, and they're looking to add a second generator, but they don't have the money to upgrade their existing generator that does not meet Tier 1 emissions or anything else to that extent. Both of those standby generators require an approval, as the entire standby generator set as a whole, all the generator systems need to comply with the exemption criteria shown in Reg 52498. If one is not shown, then that's a point where you would potentially be looking at seeking approval for those two generators. So it's a rarity, but it happens. So we're just going to take a quick look at the noise criteria outlined in NPC 300. There's the next page there. So these are the classes: Class 1 area, Class 2, Class 3, and Class 4. Class 1 area is largely dominated by the urban hum. And again, this is just point of window. This isn't outdoors point of receptions or anything else to that extent. But just to give you an overview, we've got the time of day along the sides, 7 a.m. to 7 p.m., and then 7 p.m. to 11 p.m., and then 11 p.m. to 7 a.m. They have different noise criteria. So daytime in a Class 1 area, where the noise is pretty much dictated by the background urban hum, which could typically be vehicle traffic, heavy vehicle traffic areas, or this exclusionary limit of 50 decibels. That is the exclusionary criteria you have to meet between 7 a.m. to 7 p.m. and 7 p.m. to 11 p.m., and then 45 from 11 to 7 a.m. Or the higher if the background urban hum gives you a higher 1 hour LEQ. Class 2 just appears to be the same as Class 1, but a Class 2 area is a point of reception or a residence that's in an area that represents both Class 1 and 3 areas. Class 1 is high traffic area, high background noise. Class 3 is basically out in nature, out in the farm fields. So it's a little bit of a mixture of both of those would be a Class 2 area. Class 3 area I defined. Next page. And then Class 4. Actually, we just did these are the classifications. We'll just go down to next page there. Aaron. Class 4 area is as an area or specific site that would otherwise be defined as Class 1 or 2, and which is an area intended for development with new noise-sensitive land uses that are not yet built. So Class 4 is in proximity to existing lawfully established stationary sources and has formal confirmation from the Land Use Planning Authority with the Class 4 area classification, which is determined during the land use planning process. So that gets into a little bit more detail when you're speaking to the planning departments. Now, sound level limits for a standby generator at a sensitive receptor, they're more relaxed. When you have a global adjustment 5 megawatt generator gas-fired unit, you are, again, as I repeat myself, you're assessing the noise from that, as well as the rooftop comfort equipment, any cooling towers, anything else that might be on site, could be on site truck traffic and everything else. You're going to do a cumulative noise impact with that generator, as that's not deemed a standby generator. That's prime power global adjustment. A standby generator, if you were to assess it, the noise criteria at the sensitive receptor, you're going to assess it alone. You're not going to assess that generator with other cooling towers on the roof. You're not going to assess that generator with other equipment that makes noise at the site. It's just the individual generator that you're assessing from a noise perspective. So if the noise criteria at a sensitive receptor is 50 decibels from the table above, the generator needs to be below 55 decibels. They add a 5 decibel grace for you, or 5 decibels higher than the background urban hum, if the urban hum is in fact higher than the exclusionary sound level limits. And next slide. And in addition to all the requirements we talked about earlier to secure an approval or permit for generators, prime power generators need to meet the following in-stack limits if they are to be used during peak shaving, global adjustment, etc. Next slide, please. So this is what I'm talking about. This is not a standby generator. This is to basically island the facility. The maximum intensity rates in kilogram per megawatt hour in the exhaust stack must be below the column 2 limits. So you note the column 2 limits here. You look at nitrogen oxides, it's 0.4, in essence, 0.4 grams per kilowatt hour. That's what that is. And just as a comparison, a standby generator meets the exemption criteria if it's 9.2 grams per kilowatt hour in stack. So this is basically tier 4 criteria. You need an SCR typically to bring the emission levels down to these intensity rates outlined in column 2. One other important thing that I want to bring up is that stack testing is typically a requirement every 2 years to ensure compliance with these concentrations, because we know these generators degrade over time, and we want to make sure that the in-stack limits are always being met. And these in-stack limits are to go part and parcel with the concentrations off property and the specific point of impingement limit for nitrogen oxides. So to give you an idea, nitrogen oxides has a 400 microgram per cubic meter criteria, point of impingement criteria that it must be below. Off property, when we input the nitrogen oxide emission in the intensity rates from the in-stack, we model that using Screen 3 and AirMod, and it will tell us if it's at 300 or 200 micrograms per cubic meter, tell us if it's in compliance. I'll go to the next slide. So an exemption requirement under Reg 524 for a standby generator applies to all standby generators on site. And I mentioned this already. If one generator on site does not meet the criteria, an approval will be required for all generators on site. For example, an old genset doesn't meet tier 1 or 9.2 gram per kilowatt hour emissions. If you meet the exemption criteria outlined in OREG 52498, no approvals or permits are necessary. However, if the generator is installed in a location where an adverse effect complaint occurs, the ministry may order you to apply for a formal approval. And I've already responded to a few of these, and they're very difficult because the equipment's already installed, and now we have to do some pretty cost-intensive things to get them in compliance. So that's why it's very important that FOCO and Blue Frog, we find it important to conduct an environmental assessment and install the standby generator in a location that will show compliance with all ministry criteria. In the event that someone comes by and wants to take a look, someone complains for the sake of complaining, because that surely happens, you have a document that says, my noise emissions show compliance at your location. My air emissions, we did an environmental assessment, and everything showed that we were good. So an environmental assessment is what we've been doing with generators that meet the exemption criteria. We go ahead and make sure that they not only meet the exemption criteria, but they meet the Ministry of the Environment criteria as well, in the off chance that a complaint is received. That way you don't have to end up spending more money to relocate the generator, put up costly barriers or anything else to that extent. That is an option. That is not mandatory. That is an option to everyone out there, but certainly a good one from my point of view. So I'll go through a scenario here, which is what brought me to doing these environmental assessments for generators that meet the exemption criteria. And if we go to the next slide, we'll take a look and talk about that. This is a place that I was actually at when the adverse effect occurred, believe it or not. A facility put out a generator, and let's say it's that yellow block there right beside this long-term care facility. It meets the 75 decibels at 7 meters. It meets the 9.2 grams per kilogram or kilowatt hour. So it's exempt. So most people think it's exempt. I'm going to throw it wherever wherever the shortest conduit run is, because copper's at a premium today. When you take a look at placing this generator here, we have a few problems. Let's assume this house is 14 meters away. The standby generator's at 75 decibels at 7 meters. When you measure the sound levels over at this point, it's only going to come down to about 69 decibels. So they're being impacted with 69 decibels every time that generator is put on test. Now, the sound level limit criteria for that is 55 decibels. And that also depends on what the municipal noise bylaws state as well. So is that showing compliance? No, it's not showing compliance with the provincial noise guidelines, and it may not be showing compliance with the municipal noise criteria, typically not. So that is, first off, not the best location to install that generator. When we do an environmental compliance assessment, we kind of phase those out and work with the client to do the best they can. They can certainly put the generator there and hope nobody complains. But once you install it there and then there's a complaint, sky's the limit to repair. The other thing that's happening here is this is a long-term care facility, and you have a lot of elderly patients on this west facade floor. And the administrative criteria, which is really all you can do if you're going to have a generator on the ground, the administrative criteria of having the windows closed during the periodic testing of the generator should work and should be valid, except you can't count on the patients in this long-term care facility to close those windows. They could be asleep and breathing in the contaminant emissions that are being pumped out by this generator and going into that facility. The administrative control of keeping the windows closed during testing, as long as staff at this facility take that seriously and make sure all windows and doors are closed during the periodic testing of that generator, that could work. But it's just something that you have to discuss with your client as to what will work, what won't work. Just running a little further up this, at the corner of this building, is another, I guess it's a condo, an apartment complex where they have AC units fixed in the windows, so they can't close their windows. And these emissions were going right up and inside those windows as well, which is off property. and we can't tell someone off property or a building off property to close your windows to make sure you're in compliance. So it's very important from our perspective, because we've been called in so much to try and find a solution to a poor installation, that it's my suggestion that people take a look at doing a quick environmental assessment just to see if somebody does complain, am I already in compliance with ministry criteria? At which point, if you're working with us, you will be, and you don't have to worry about doing too much further. So that's pretty much it for me. I'll pass it on over to the Daryl.
Thank you very much, Greg, for that highly technical discussion. Over to you, Daryl.
Great. All right. Thanks, everyone. We're getting 15 minutes to the top of the hour here, and I want to leave a bit of time for questions and answers as well. So I'll try and move quickly through this portion here. Greg, yeah, thank you for the technical portion of things here. I'm trying to lean a little bit more to the practical side of things here after we get an emissions control system into the field. As I mentioned earlier, I have a lot of experience in our aftermarket and our service groups and service organizations working with products that are in the field, and just wanted to bring up some common considerations that should be made when you're putting one of these things into service or evaluating where that's going to be. So several different styles and several different manufacturers of after treatment systems. So this isn't meant to be a exhaustive maintenance application discussion. So make sure you're still working with your SCR manufacturer, your after treatment manufacturer, as well as any other equipment that's on site to make sure you're following their recommendations as well. When it comes to installation and design considerations, main thing that we usually look at is safety. And what we see often in the field is these are rooftop mounted on top of enclosures, not easily accessible. And one thing that comes up repeatedly is tie-off locations. So a lot of what Greg was mentioning as well, when it comes to stack testing and compliance testing, you do have to get up to the stack. You have to get up to the controls that might be on the side of the SCR. You might have to inspect the catalyst, etc. And when you don't have a proper tie-off location, a proper way to access that port, now we're into potentially renting man lifts and working with some other engineering firms to make sure that we get this safely accessible, which can cause delays in an emergency, but it can also cause added expense later down the road. So yeah, as far as safety, accessibility, and also ancillary equipment that's required to operate the after treatment system. So that could be pumps, air compressors, lines, tanks for storage with DEF, kept in climate controlled areas and accessible to whoever your maintenance provider might be. DEF in particular does freeze below 11 degrees Celsius for the standard concentration of 32.5%. Freezing of DEF does not damage it if it happens occasionally and doesn't hurt its effectiveness, but you do have to have means to thaw it if it does freeze. And if you have bulk storage of DEF for potentially extended runs, if that's kept outside, which we do see quite often, there'll be a skid of barrels of DEF available there for you in case it's needed, but it's frozen solid because it's the middle of the winter and it's useless to you. So something to keep in mind when you're working with this. Additionally, so the team earlier did talk about mobile applications as well. So we do have SCRs on mobile equipment as well. Confined spaces are a possibility here. Oftentimes they are squeezed into enclosures, squeezed into containers in either a radiator plenum or inside an engine compartment that could be considered a confined space. So that's something to keep in mind. And also the same thing with ancillary equipment here. So freezing of DEF is often unavoidable in these situations. Most manufacturers or all manufacturers will have a method to thaw that DEF, understanding how that system works and how it will be available. If it's electric heat that's used, or if it's engine coolant, or if it's some other source of heat that's thawing that DEF, ensuring that system is operating properly, because if it's not within the time limit allowed by the ministry or by regulation, you may not be showing reduction if your DEF is not thawed enough to start dosing the SCR. Okay, go ahead. From a maintenance perspective, so as I mentioned, oftentimes these are coupled with a reciprocating engine or a diesel gen set or a gas generator set that will have a robust maintenance plan associated with it, or you may have a contractor coming in to perform that for you. But ensuring that you are either combining that with the SCR maintenance or having those contractors work with each other closely because they obviously rely on each other quite a bit. So concentration of urea is a concern at a lot of these sites, particularly some of these gensets that don't run often. It's often a good design concept to put as much DEF on site as possible so that you don't have to refill it very often. However, if that means that DEF is going to sit there, sometimes in high temperatures during the summer for many, many years, it can degrade the concentration of the urea within the DEF fluid. So there are simple tools available, and your maintenance providers can also do this as well to ensure that that concentration is staying in an acceptable range. Water evaporation, high temperatures or poorly sealed containers are all reasons why that could cause an issue. Cleanup of DEF as well. So we do have seen when DEF freezes, it turns into a white crystal chalk type material that is mildly corrosive. So it is important to get that cleaned up quick. Check the MSDS of the product and that you're being supplied just to make sure your rate safety precautions are being used during that cleanup. But it can quite easily clog ports, disrupt sensors, plug lines when it dries, and that means when that generator might be called to run, days, weeks, months later, the DEF will not flow because you've got dried crystallized urea in some critical areas. It can also damage electronics. So if it's a larger spill around the control system, it can be a challenge that should be addressed right away. Access to some of these facilities as well. So as I mentioned earlier, making sure that we have the ability to get into them as well, because we are working on not just it sometimes gets neglected because there's no moving components, right? An engine, everyone knows you've got to maintain that engine, but the SCR needs to be maintained as well. And particularly for certain callouts, if sensors are failed, if the bricks are not reducing properly, we have to get up and get in there to take a look. Some examples in the bottom right there that actually include sound attenuation in addition to an SCR. You can see how that starts to compound the ability to get in and actually test, maintain, and repair. So something to keep in access is always something to keep in mind when looking at installing and deploying equipment like this. And that includes the ancillary equipment. So when it comes to a maintenance contract or a maintenance plan that you have in place, oftentimes some of the items that are not specifically the engine or the SCR themselves can be neglected. You could have air compressors in order to purge lines. If that air compressor is not part of a maintenance plan, eventually that's going to cause a problem. You're not going to purge your lines properly. You could have buildup in those lines and it'll cause issues down the road. So make sure we're taking a whole system approach to maintenance and operation here. Go ahead, Singh. And then testing and maintenance. So again, ensuring you're aligning your SCR maintenance and testing with your generator testing. It is the best time, obviously, to make sure that you're seeing the right reduction, you're seeing the right emissions control. As Greg mentioned, there are repeated stack tests that are needed in some situations, and you don't want to find out that you may have a challenge, you might have a adjustment or a recommissioning that needs to happen on some of your equipment. The day that you've got the ministry or an environmental consultant out there performing a stack test, if you're performing your maintenance regularly on your own, you should have well enough warning to make those adjustments prior to a critical test situation. So external test equipment, there are permanent installs for that equipment as well, or many service providers out there, us and Greg included there, that can provide that service for you if required. And that's all I have. Like I said, I want to leave some time for the questions and answers there, Singh.
Thank you very much, Gerald, for the discussion on installation and maintenance requirements. So for questions, we have received some questions already as part of the initial invitation. However, anyone can email me questions. My email address is shown on the screen. It's SSINGH, or one can use the Q&A function on the on the webinar itself. So the first question is to Omar, and this pertains to the EPA regulations. We've heard about Tier 1, EPA, Tier 1, Tier 2, Tier 3, and they were mentioned in what some of the qualification requirements for standby and so forth. Is there anything after Tier 4? Is the US EPA working along some lines on anything else that might be coming after Tier 4 emission regulations?
So now the final thing is EPA Tier 4 final. That's the expected emission levels. And now they're going towards EPA Tier 5. So that's what's being discussed now. And this will be basically introduced, I think, 2030 or the beginning of 2030. This is what they are looking at, but it's a 60 to 90% reduction in NOx. That's the most significant thing, but it's very challenging from a technological side now. So I think we like have 4 or 5 years to see that introduced because technological wise very challenging.
Okay, so thank you very much. We've got some questions on the Q&A. Except for Safety Power, are there any SCR manufacturers available to supply SCR with Tormont Genset? Yes, there are. And certainly we can discuss on a one-to-one basis. If there is a customer preference for a particular SCR, we can certainly provide that. The other question is, what are the noise restriction guidelines, regulations for other provinces other than Ontario? Example, Alberta. Greg, would you know anything along that?
That is a good question. I only specialize in Ontario, so I haven't read that legislation yet.
Okay. So sorry if we're not able to respond to that.
Brent, there could be a follow-up that we could take there to connect you with, we have not a sister company, but we do have companies that we work with out in the Alberta area as well that would be more expertise in that area. I think the important thing, and partly what Greg brought up as well, is there are very specific provincial regulations as well that need to be taken into account. But yeah, if anyone has a specific province they're having issues with, we can definitely help connect with the experts in that area.
Thank you, Daryl. So some people say that the solution to pollution is dilution. Greg, is that a valid statement?
Half valid. Solution to pollution is dilution. A lot of the times, if we can't get into compliance at a lower stack level, we kind of try raising that stack up a little bit more, give it a little bit more flow time in the air, and reducing concentration. But at the same token, we have come great lengths to have proper pollution control equipment to be able to install down at the source. And the SCRs that Daryl's talked about are one of them.
Okay, thank you very much, Greg. One question about the use of urea and ammonia. How do we minimize ammonia slip into when it's used in an SCR on a generator set?
Yeah, I can take that. So when we're doing our initial commissioning, our initial startup of those SCRs in the field, there is a very controlled way of commissioning the dosing of urea within an SCR. So we aren't starting from maximum dosing and trying to back down. We're gradually working our way up to find out exactly how much urea dosing needs to happen to get the desired reduction with all of our test equipment installed. That's going to give you a baseline. So where ammonia slip occurs and ammonia starts flowing out of the stack, which is obviously something we very much want to avoid, the only way for that to happen at that point is to introduce more and more urea into the system. So in a situation where you're you're not meeting reduction and the solution is just increase urea, that's when you start getting into the risk of ammonia slip. So there is a pretty clear indication that that's going to be something that's on the table, and it needs to be addressed at that time. So if commissioned properly and setting a proper baseline of urea dosing to expect is your best way to ensure that that's not a challenge or not something that's being introduced later on.
Thanks, Daryl. We have another question. To qualify for the standby generator under Reg 52498, exemption from Section 9 of the Act, approval is required. And I believe the annual limit is 60 hours. Is MECP expected to put forward the approval soon?
This is to increase from 60 hours right now.
No, is required. I believe the limit is 60 hours. But to put forward an approval soon?
Put forth
is
an
it-
approval.
Is it 60 hours or is there a proposal by MECP to increase it?
It's 60 hours right now. It sounds like the question's heading its way towards whether or not they're going to increase it.
Sounds like it.
I'm just pulling the Reg 52498 up. Yeah, right now, Section 412, each electricity generation engine that is part of the system is used and operated for the purpose of testing or performing maintenance for a maximum of 60 hours in any 12-month period. I haven't heard of any amendment coming through. That doesn't mean it's not, but I haven't heard of any amendment.
Is that something that a variance could be applied to, or is that generally pretty strictly enforced?
I would suggest strictly enforced. They want to separate the two, that because a lot of these standby generators have the capability of islanding some small mechanical shops and things of that nature, and they don't want generators operating for that purpose. So they want to see the records and the data that show that you've only put this on test for 1 hour a week, or thereabouts, just to be below 60 hours.
Okay, thank you very much, Greg. Any other questions? I don't see anything on the Q&A. So thank you very much for joining in today. Greatly appreciate your time, and hopefully we've provided some insights to you on not only generator set emission regulations and noise regulations, but also some of the installation considerations as well. Our next webinar is in July, which is next month, and this will be based on VisionLink, which is Caterpillar's cloud-based fleet management and telemetrics platform. This actually was highlighted in last month's webinar on our data centers, in which data management and collection was one of the prime subject that was raised. So look forward to that webinar coming up next month. And once again, thank you very much for joining in today, and we look forward to your participation in future webinars. Take care.